For thousands of years, humanity has stood in the shadow of the Great Pyramid, stared up at those massive sun-baked stones, and asked one seemingly unavoidable question: how on earth is a monument like this even possible? Well, welcome to this explainer. Today, we're going to unpack the reality behind one of the absolute greatest achievements in human history. So let's just dive right into this, because what we're looking at isn't some magical anomaly. It's actually the ultimate triumph of physics, planning, and human organization at a scale that, frankly, still feels pretty impossible today.
You know, when we're confronted with something as massively imposing as the pyramids, the human mind naturally kind of leaps to the supernatural, right? We just assume that because we can't easily picture ourselves doing it, the builders must have used magic or maybe otherworldly help. But what if we've literally been asking the wrong question this whole time? The true secret of the pyramids isn't found in magic spells or some lost ancient technology. It's actually found in recognizing that this is the greatest logistical puzzle in human history. To really get it, we need to completely shift our perspective from how did they do something magical to what kind of system can move massive objects with human hands and simple tools.
So let's start with Section 1, the logistics of stone. This is a logistical problem made completely visible.
And that brings us to our first major shift in thinking. A pyramid is essentially a massive logistical problem laid bare. It's not just a monument, it's a physical record of a grueling engineering process. Because you see, a pyramid isn't built simply by stacking stones on top of one another. No way. It's built by methodically solving a continuous chain of physical challenges, one right after the other, until that iconic final shape emerges from the desert. Let's quickly break down the specific constraints the builders had to manage all at once. First up, you have weight. Stones are incredibly hard to move, forcing builders to master friction and leverage. Once you figure that out, well, you hit distance. Those massive stones had to travel from the quarry to the site, making transport a huge hurdle. Solve that, and you face height. As the structure rises, you suddenly need a way to move material vertically, not just horizontally. Underpinning all of this is organization, because raw labor is entirely useless unless thousands of workers act as one productive system. And finally, precision. If these massive blocks don't align correctly, tiny errors at the base will compound into a total catastrophic failure at the top.
Which brings us to Section 2, winning the friction war. Out here, resistance is the real enemy. Let's look at that very first obstacle and see how this builds. Because as stones get larger and larger, the engineering challenge completely shifts. It's no longer about simple human strength. A stone in a quarry must be separated, moved, and controlled without breaking it. You aren't just fighting the weight of the stone, you are literally fighting the ground it sits on. Resistance, specifically friction, is the absolute enemy here. So the crucial point is summarized perfectly by this question: how did they reduce resistance enough that human labor could actually do the job? That question sits underneath every single serious engineering theory about the pyramids. The question isn't, could a human lift it? Because, well, the answer is obviously no. The question is how these ancient engineers manipulated their physical environment so that the limited force generated by human muscles could actually get the job done. Just think about raw human pushing effort and contrast that directly with the engineered sledge technology they actually developed. The builders didn't try to defeat physics, they used it. By placing a heavy stone on a wooden sledge, they turned a rough, unpredictable block into a controlled load. And what's absolutely fascinating is the real genius of wet sand. By pouring just the right amount of water onto the sand right in front of the sledge, they stiffened the sand, preventing it from bunching up, and drastically reducing the friction. It's a real game changer. They made the surface resistance consistent, allowing a team of workers to literally glide massive weights right across the desert. It completely shifts how you think about simple human labor.
Moving on to Section 3, elevation and the ramp, because height completely changes the rules.
Of course, moving a stone at ground level is only half the battle, right? Once that block reaches the base of the pyramid, height completely rewrites the rules. As the structure rises, the main engineering challenge shifts dramatically, from moving things sideways to moving them up. And you can't just drag a 2-ton block up a sheer cliff face. This is exactly where the concept of ramps enters the discussion. The brilliant thing to understand about ramps is that they don't magically remove work, they just redistribute it. Instead of lifting a stone straight up, you spread the lifting effort across a much longer distance. Think of it like pushing a heavily loaded wheelbarrow up a gentle hill, instead of trying to hoist it directly onto a roof. The most plausible theories suggest a whole family of ramps was used, depending on the elevation. Down at ground level, massive straight ramps could handle the bulk of the early stones. At mid-height, they likely used zigzag or switchback ramps. And at the very upper levels, side ramps built directly along the structure itself would have been absolutely necessary as the working space shrank.
And this brilliantly illustrates the next massive hurdle, precision. As you're hauling these blocks up those ramps, you can't just drop them anywhere. Workers use tools like plumb bobs and A-frame levels. Continuous leveling, strict reference lines, and repeated checking kept the massive geometry true as it grew upwards. Remember, when you're building a giant puzzle with millions of blocks, being off by just a tiny fraction of a degree at the bottom means the four corners will entirely miss each other at the top. The precision wasn't just to make it look nice, it was literally structural life or death.
Now for Section 4, organizing the human machine. This is the ultimate coordination problem.
Obviously, none of this physics matters without the manpower to actually execute it. But 10,000 people with no plan? That can actually be way less effective than a few hundred people working in a carefully ordered system. Large construction projects are coordination problems just as much as they are physical ones. Massive organization was the absolutely crucial piece of ancient engineering that made the Great Pyramid possible. Think about how highly specialized these human teams had to be, acting together as a single productive machine. The workforce was divided into strict operational units. You had the quarry teams, who were the specialists at the source, cutting and shaping the blocks right out of the bedrock. Then the transport teams, whose sole job was moving the stone via those sledges along meticulously planned routes. Up on the pyramid, you had placement teams, the precision engineers positioning the blocks with exact measurement and alignment. And perhaps most importantly, the supply teams. They had to keep food, water, and timing completely synchronized. This chain is incredibly vulnerable, you know? If the supply team fails to deliver water, the transport team stops, the placement team waits, and the whole human machine just grinds to a halt.
Finally, we reach Section 5, Intelligence at Scale. The evidence points directly to deep planning.
So why do scholars and engineers find these logistical methods so totally plausible? Because the physical evidence points firmly to deep planning, human tools, and scaled intelligence, not magic. When we look at what was left behind, it all tells a very clear, grounded story. Let's just look at the sheer scale of the evidence for a second. 2.3 million. It's a staggeringly difficult number to even wrap your head around. That is the estimated number of individual stone blocks in the Great Pyramid. Every single one of those 2.3 million blocks had to be quarried by hand, moved by hand, and placed by hand. It required a perfectly tuned organizational system to process all of that.
4,500. The Great Pyramid has been standing for roughly 4,500 years. This isn't just some fun trivia fact. It is undeniable physical proof that this massive organizational system and their relentless pursuit of precision actually worked perfectly. The foundation hasn't cracked, the structure hasn't collapsed, their math was totally flawless. And roughly 20,000. That is the estimated workforce. Not a horde of millions. And importantly, pushing back on some long-held pop culture myths here, these were absolutely not slaves. The archaeological record clearly shows they were highly coordinated teams of organized laborers, respected for their work, housed, fed, and managed with incredible efficiency. When you put it all together, the tool marks still visible on the stones, the remnants of massive work camps, the transport traces left in the desert, and the deliberate microscopic alignment of the structure itself, it all points to the exact same conclusion. The ancient Egyptians had the exact organization, the specialized tools, and the deep physical understanding required to solve a remarkably hard problem. They didn't need magic, they had logistics.
As we wrap up this explainer, I really hope you've moved from wondering how a mystery was possible to seeing the actual, tangible system that made it a reality. The mystery has actually become intelligible. The pyramids represent disciplined intelligence applied at a massive scale. And frankly, the real story is just so much more impressive than any supernatural explanation, because it relies on something uniquely human: the patience, the dedication, and the brilliant design required to repeat small, correct actions thousands upon thousands of times.
Which leaves us with a pretty inspiring final thought. If a society 4,500 years ago could organize themselves with enough discipline and intelligence to build a literal mountain of stone, using nothing but ropes, sledges, and human ingenuity, what seemingly impossible problems can disciplined human organizations solve today? It's definitely a question worth thinking about. Thanks for joining me for this explainer. Keep asking the right questions, and I'll catch you on the next one.